Greetings. My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Imagine you are looking at the height of every 10, 11, and 12-year-old in Georgia. That is a lot of people and a lot of numbers. But what if you could look at just one number and get an understanding of what the heights are? We calculate and understand summarizing numbers like this using statistics. In descriptive statistics, we often look at measures of central tendency. These values give a snapshot of the center of data, summarizing all the data down to one number. With a center value, we can compare it to another group's center value and determine which values are typical and if any are outside of a normal range. Furthermore, inferential statistics often requires us to find the center to make predictions and test hypotheses. There are three common measures of central tendency. The first is called the mean, also known as the average of a dataset. Let's begin with the idea of fair sharing. Imagine you have a party where everyone brings some cookies. Everyone brings a different amount, with some friends bringing a few, some bringing enough to share, and one friend bringing enough to feed an army. To be fair, the cookies are divided evenly between everyone who comes to the party, even if they didn't bring any cookies. The mean is like the number of cookies each person gets. Everyone gets the same fair share. The mean falls somewhere in the middle of the data. However, it is greatly impacted by the numbers that fall outside the normal range. Another way to think about the mean is the star rating system you see on many platforms. Imagine you are shopping, looking to rent a movie, or staying at a hotel. Each of these might use a 5-star rating system, with 1 star being poor or terrible and 5 stars being the best or excellent. Suppose you are looking at a hotel. The number of stars shows the average of what people think about the hotel. If lots of people think the place is just okay, reasonably clean, but not all that nice, you might see a 3 2/10 star rating. Quite a few people rated the hotel a 3 as just okay, and some people said it was not great with a 2, or that it was decent with a 4. A few people may have had a really good or a really bad experience. All of these balance out to the okay rating of 3 2/10 stars. To calculate the mean, we find the sum of all the values in the dataset. Then divide the sum by the number of values. Jake offers the following prices for services at his auto repair shop. To find the mean price, add up the prices of the services and divide by 8, as there are 8 services he offers. The mean cost for Jake's services is $232.88. We might use this number to compare prices with other auto mechanics in the area. This could identify how Jake's prices compare to other shops. We use the mean a lot. We find the mean when we want to. The mean is a measure of central tendency, which means that it represents the middle of the data. The mean is a versatile and powerful statistical tool to analyze data and make informed decisions. The second measure of central tendency is called the median. The median is the middle number in a dataset when the numbers are arranged in order from smallest to largest. Imagine taking everyone in your class and lining them up by height. The person in the middle is the median. Or think about watching a 20-episode series. The end of episode 10 represents the middle of the show. Half of the show came before this point, and the other half of the show will come after. Unlike the mean, the median is not greatly affected by extreme values. If there is a very large or very small value in the dataset, it is just another data point. To calculate the median, we start by lining up all the data from least to greatest. We then count from each end until we find the number in the middle. If the median falls between two numbers, we find the mean of the middle two numbers and use that as the median. Jake offers tires in the following diameters. For cars, he has 13, 14, 16, 17, and 19-inch tires. For trucks, he has 15, 18, 20, 21, 22, and 25-inch tires. For SUVs, he has 16, 17, and 20-inch tires. To describe this dataset, let's find the median of the tire diameters he offers. First, I line up the numbers from least to greatest. Notice that numbers appearing more than once in the original dataset still appear more than once when ordered. Now we count from each end to find the middle. Counting from each end puts the median between 17 and 18. Since there is not a single number in the middle, we find the mean of the two middle numbers, 17 and 18. Add them together and divide by 2 because there are two numbers. 17 plus 18 is 35. 35 divided by 2 is 17 and 5/10, or 17 and a half. We could use this value along with others to see if Jake offers a typical selection of tires or if his tires run on the smaller or larger side. We often use the median because it tells what the middle is. Half of the data is smaller than this number, the other half is larger. We use the median when we want to know the middle income of a household in a country or the middle price of a house in a neighborhood. When we compare the central tendency of two or more data sets, such as the median salary of men versus women or the median test score of students from two different schools. When we detect outliers in a dataset, such as the median height of students in a class or the median weight of cars on a highway. When we set benchmarks for performance, such as the median time it takes to process a loan application or the median number of patients treated in a day. Or when we make decisions about resource allocation, such as the median salary of employees in a department or the median cost of projects. The median has many uses in the real world and various careers. The median is a robust and reliable statistical tool to analyze data, make predictions, and make informed decisions. The third most common measure of central tendency is called the mode. The mode is the most frequent number in a data set. For example, if you have a dataset of eye colors of 10 people, the mode would be the eye color that appears most often among the 10 people. We often use the mode when we rank things to know which appeared most often. To find the mode, we need to organize our data. If you already determined the median of your dataset, your data is already organized. Organized lists and tally marks also can help to find the mode. Jake is looking at the vehicles he serviced this week. He performed services on the following types of vehicles. What is the mode? Or which type of vehicle did Jake service most often this week? Since this data is not numeric, we cannot order it from least to greatest. However, I can alphabetize the types and use tally marks to find which occurs most often. Looking at this list, the mode of the dataset is sedan, meaning that Jake serviced more sedans than any other type of vehicle. The mode is a simple statistical tool used to identify the most common value in a dataset. While it does not necessarily point to the center of the data, it provides insights, especially if the data is concentrated to a few selections. The mode helps us make informed decisions about a variety of topics. Sometimes one measure of central tendency is more useful than others. Let's look at a few situations to see how different measures of central tendency help to identify different insights into the data. Before the examples, let me define the word skew when dealing with a data set. We call a data set skewed when very large or very small values pull the mean away from the actual center. One area where we often use measures of central tendency is income. The mean income of a population can be used to understand the overall level of wealth in that population. However, a small number of very high earners can skew the mean income. The median income, on the other hand, is less affected by outliers. Therefore, the median income can provide a more accurate picture of the typical income level in a population. The same is true when it comes to house prices. The mean house price in a neighborhood can be used to understand the overall values of homes in that neighborhood. However, the mean house price can be skewed by a small number of very expensive homes. The median house price, on the other hand, is not affected by outliers. Therefore, the median house price can provide a more accurate picture of the typical value of homes in a neighborhood. The mean age of a population can be used to understand the overall age distribution of that population. However, the mean age can be skewed by a few very old or very young people. The median age, on the other hand, is not affected by outliers. Therefore, the median age can provide a more accurate picture of the typical age in a population. However, if the population does not contain outliers, the mean can provide a better picture, especially when the data is concentrated around certain ages. Another example is the wait time at a restaurant. The mean can be used to understand the typical wait time for a table. However, the mean wait time can be skewed by a small number of very long wait times. The median wait time, on the other hand, is not affected by outliers. Therefore, the median wait time can provide a more accurate picture of the typical wait time for a table. The mean and median can present different information because the mean is sensitive to outliers while the median is not. This means the mean can be skewed by a small number of very high or very low values. The median, on the other hand, is not affected by outliers. The median works well when the data is skewed, but the mean provides a better picture when the data is evenly distributed. The mean and median can be compared to understand the distribution of a set of data. If the mean and median are close in value, it indicates that the data is relatively evenly distributed. However, if the mean and median are significantly different in value, it indicates the data is skewed. In my mathematical world, I have one little problem. Some of my friends said they need to find or work with measures of central tendency often. Help me understand some of their situations. Heather is calculating her average weekly hours for the month. What is the mean number of hours she worked this month if she worked the following number of hours? Last month, she averaged 41 25/100 hours each week. Did she work more total hours this month or last? Claudia's soccer team scored the following number of goals across their last 15 games. What is the mode of the number of goals? How does this value represent the dataset? Kaji is tracking the time he spends with patients in the intensive care unit at the hospital where he works. During his morning rounds, he spends the following minutes with his patients. His typical mean is 22 2/10 minutes, with a median of 25 minutes. How does this morning's times compare to his typical measures? What might that mean? Christine is tracking the transmission of flu in a community. She measures how long individuals are contagious to understand how the flu is spreading. The following are the hours some people are contagious after being infected. She said in many cases they need to use the median instead of the mean to describe the center of a data set. Using the sample data, explain her reasoning. Adina found that 8 people from a list of suspects share a similar fingerprint characteristic. Their heights in inches are as follows. What is the mean of the heights? Why is the mean a good measure of central tendency for this dataset? Van designs video games and investigates a level's difficulty. With a test group, he recorded the times to finish the level in seconds as follows. Is the data evenly distributed or skewed? What measures of central tendency tell you this? Mr. Jones teaches science. He explained to a student that they have 6 test grades this marking period. The student was absent and still needs to make up 1 exam. The current grades are as follows. How does taking the exam without preparation and doing poorly, say a 60%, change the mean? What if the student does just okay with an 80%? Why is this happening? If you were Mr. Jones, what would you recommend to the student? Take a look and you will see a mathematical world around you filled with data. In statistics, mean, median, and mode are like storytellers for our data. The mean is the average, giving us a central value. The median is the middle value, not affected by extremes. And the mode is the most common value, highlighting what happens frequently. These three are common measures of central tendency, and each help us summarize and understand a dataset. Descriptive statistics like mean, median, and mode simplify working with large amounts of information. Understanding their creation, meaning, uses, and limitations gives you great power in a world filled with data.